Okay guys, so in this one I want to go over number 9 from the worksheet. That one, I don't have to let you all guess which one it is. It's the combined gas law, that section. So for that one, you're going to use the same law the whole time, which is going to be P1 times V1 is equal to, or divided by T1, excuse me, is equal to P2 times V2 divided by T2. Okay, so we're giving you that one. So we already know which one it is. The trick is just figuring out how to solve the problem. So number 9 reads 800 ml sample of gas right there. We have 800 ml, okay, sample of gas. So we need to ask ourselves what unit. That's a volume. So that's volume 1 of gas is initially at STP. So those letters, you need to remember what they are. Okay, STP is going to equal to 0 degrees C all the time and 1 atmosphere. Okay, so that tells us right there some other numbers we need to. So we know our temperature 1 is going to be 0 degrees C. Okay, and we know our pressure 1 is going to be 1 atmosphere. Okay, so that's what we're starting at. And the rest of the problem reads that it is compressed to a volume of 240 ml. So that would mean that other number, 240 ml, okay, that's going to be our volume 2. Okay. Now, the rest of the problem also tells us that the temperature has increased, so now we know our T2 to 25 degrees C. Okay, so temperature's gone up. And the final part of the question is actually that question where it says, what is the pressure of this? So we are looking for P2 here. That's our unknown. Okay. Now we know using that problem, before we start plugging everything, that equation, but before plugging everything in, we have to do some converting. Okay. So first thing is we'll start with the easy ones. Pressure, we're fine, it's our ATM. So an atmosphere is the unit we want, we're good. Now, the temperatures we have to change. So that's an easy fix. We just need to add 273. That will change us to Kelvin. Okay. So our actual T2 is going to be 273 plus 25. That should be 298 Kelvin. Okay. And this one is 273 plus 0, so that's going to be 273 Kelvin. Okay. So that's where we get these numbers. We're using that because we need to have these same units. So we're good here. We can cross that part out with the degrees C. Okay, so we're done there. And now for volume. Okay. Now volume needs to be in liters for this. Okay. We don't want to be in ml. You can keep an ml and convert it at the end. You actually won't need to convert it because you're going to end up with a pressure. But I like to make sure you work with it as is. So that's an easy fix. Basically, you just take that number of mLs and divide it by 1,000. So that's going to equal to 0.8 liters. Okay, so we're good there. And that 40 is going to be 0.24 liters. Okay, and so those are the numbers we're going to use. Now we can plug it in and see what we're going to have to do mathematically to solve this problem. So our pressure 1 is over here, that's 1 atm, so that's going to be 1 in parentheses, and our volume 1, which is 0.8. And that's going to be divided by our temperature 1, which is 273. That is going to equal, on the other side, our pressure 2, which is unknown. So that's going to be our x times our volume 2, which in this case is 0.24, divided by our temperature 2, which is 298 Kelvin. So at this point, again, it's just become an algebra problem. And I told you which law to use, so all you just kind of plug it in. The hard part here is make sure that everything's in the right unit. Now the good thing is, if you chose not to convert some things, ultimately you'd likely end up with the same answer. And that's the beauty about these, is that both sides are in the same unit, you're fine. But I like to keep it all standard all the way through. So here we just do some math. So at this point, it's 1 times 0.8 divided by 270. So this side can actually go ahead and solve. I did that in my calculator, and I got 0.0029 is equal to, and then 0.24 times x, so that's 0.24x divided by 298 still. Now, if I want to get rid of that 298, I can multiply both sides by that. Want to do this? These two cancel each other out, so this is going to equal on this side 0.24x. And this is where the math gets tricky, so you have to make sure you plug that in. 298 times 0.0029, I got 0.86. And to solve for x, we divide both sides by 0.24. That cancels, and leaves me with x being In this case, I got 3.6. Now X is a pressure 2, which is the same unit as this, which means this answer is going to be in atmospheres, ATM. And if you think about it, it makes sense, guys, because it says that the sample was compressed, which means if you take a sample and you end up shrinking it down, it makes sense the pressure is going to increase because of less space. So that is a good answer. Okay, so that made sense.